Okay, we're going to do some erasing again. Notice how this one is different. We're told that this blue graph here, this original graph, is actually a derivative graph. And we want to find out what the original graph looked like. And we want to find out what the second derivative looks like. Based on what we did in the last question, would you say that the green graph or the purple graph is going to be easier to draw? Purple, because it goes in the same direction of what we did before, right? We've been working from a graph to the derivative graph. So let's do the purple one first. Okay? If we were dealing with this, in fact, the purple one would be exactly the same as what we had in our last one. We would say, well, I know that there is some value right here where f prime of x, in this case would be f double prime of x, is equal to 0. And because of that, I would have a derivative here. I mean, a x-intercept there. And we're going to base it on the same slope as last time. Because we knew that our original function was increasing before and decreasing after. So our f double prime graph has to be positive here and negative there. Now, going to our blue graph. Now we have our derivative graph. Going to our green graph. We have our derivative graph. Okay? If this is our derivative graph, it tells us some stuff. It tells us that at this point, which is 1, 2, 3 to the left, I don't know that that's 3. But I have that point there, and then there's 1 to the right. Those will be 2 points where our derivative is equal to 0. So we know that our derivative is equal to 0 at 2 points. What does that tell us about our original function? That those have to be max or min or maybe inflection points that are stationary. Okay? From our blue graph, it also tells us that on this section, can you see that f prime of x is negative? Because our blue graph is below the x-axis. Between these 2 points, our derivative graph is positive. And after this point, our derivative graph is negative again. Well, that tells us something about our original graph. That tells us our original graph is decreasing, then increasing, then decreasing again. So now we would have to go about graphing our final graph. Okay? We're unable to tell exactly where our maxes and mins are going to be because we can't plug them back into our original equation. But we know that we're going to have a local minimum somewhere with this point. Okay? We know that we're going to have a local maximum somewhere with this point. And from our purple graph, we know we have an inflection point in between. And our graph is decreasing here and increasing afterwards. So this gives us a way to estimate what our graph would be. Just based on the ideas that we have. And again, if you think that the original graph that's shown here is an x squared graph, it would make sense that the graph that we get is an x cubed graph.